Today we'll discuss the thermodynamics. Thermodynamics is concerned with the energy relationship involving the heat, mechanical energy, and the other aspects of the energy and the energy transfer. The principles of thermodynamics are usually stated with reference to a well-defined system, that is a thermodynamic system. And we can define a thermodynamic system as the one which interacts with the surroundings. And this interaction is in the form of either transfer of heat or the mechanical work. An example of the thermodynamic system is the ideal gas contained in a cylinder. We can suppose a cylinder fitted with a piston, and this piston is a massless and frictionless, and the cylinder contains the ideal gas. So we can say this is one of the example of thermodynamic system. So a ideal gas contained in a cylinder fitted with a massless frictionless piston can be considered as a thermodynamic system. And state of a thermodynamic system can be specified by the variables PVT. Here P refers the pressure of the gas, V is the volume, and T is the temperature. And this is the absolute temperature, that is in Kelvin scale. And these three variables are related with the ideal gas equation, that is PV equal to nRT, where N is the number of the moles of gas and R is the universal gas constant. So we should be very clear about the definition of what is the thermodynamic system and what is the states, and these are the state variables. Pressure, volume, and temperature can be said as the state variables. Next, we discuss the law of thermodynamics. One of the law is Zeroth law of the thermodynamics. As per this law, if the two bodies A and B are in thermal equilibrium, similarly, if A and C are also in thermal equilibrium, then as per the Zeroth law of thermodynamics, B and C will also in thermal equilibrium. It means, say this body A is in thermal equilibrium with B, and same body A is also in thermal equilibrium with body C. It means, as per the Zeroth law of thermodynamics, that B and C are also in the thermal equilibrium. Two bodies in thermal equilibrium means they are at the same temperature. It means if temperature of A equal to temperature of B and temperature of A equal to temperature of C, this implies that temperature of B will also equal to temperature of C. This is the first law of thermodynamics, and it is a consequence of the conservation of energy for the gaseous system. So we have to remember this, that first law of thermodynamics is the consequence of conservation of energy. We define one of the term, that is U. This is the internal energy of a system. U represents internal energy of the system, and it includes all kinds of the energy possessed by the atoms or the particles that comprises the system. And first law of thermodynamics in equation form can be written as delta Q equal to delta U plus delta W, where delta Q is the heat supplied to the gas, delta U is the increase in the internal energy, and delta W is the work done by the gas. In differential form, we can write dQ equal to du plus dW. Here dQ is equal to NCP dt. Here N is the number of moles, dt is the small change in temperature, and Cp is the molar specific heat at constant pressure. Similarly, du, that is the small change in the internal energy due to the change in temperature dt, is given by NCV delta T or dt. Here Cv is the molar specific heat at constant volume. Molar specific heat already discussed in earlier lectures. Here we can say this molar specific heat at constant volume is the heat required to raise temperature of 1 mole gas by 1 degree Celsius at constant volume. Similarly, if we write for constant pressure, then the only change is in the definition is at constant pressure. There are sign convention. If the heat is supplied or given to the system, then heat is taken as positive, that is greater than 0. And if heat is taken from the system, then it is taken as negative. Similarly, if work is done by the system, then work will be positive, that is greater than 0. And if work done on the system, that means it compresses, in that case, work will be taken negative or less than 0. An increase in internal energy will result into the increase in internal energy delta U is 0, and it is the case when temperature increases. If temperature decreases, then we will say that there is a decrease in internal energy, that is delta U is less than 0.